Okay, let's look at another concept, electrical loads. Electrical loads. Remember, we said that your electrical loads affects many things about the solar system installation. Let's take a closer look at the electrical load. This is gotten from chapter 3, chapter 7 rather. This is module 6, and this information is an extract from chapter 7 of solar exclusive. Let's dive in. What do we mean by electrical loads? So basically, we had already said that electrical loads are objects that uses electricity. Your table is not an electrical load. Your bed is not an electrical load. Your fridge is an electrical load. Your phone is an electrical load. Your AC is an electrical load. Your television is an electrical load. Your laptop is an electrical load. So those objects or appliances, let me use appliances, that uses electricity, they are called electrical loads. And there are the reasons why we install solar, why we go solar. So electrical loads are those appliances that make use of electrical energy. So the electrical power may either be AC or DC. Remember, when we were talking about types of solar system installation, we made mention that some systems are DC, some are AC, some are day use, as the case may be. But basically, your electrical load can either be AC or DC in nature. Example, your television. Example of an electrical load is your television, your AC, your laptop, light bulb, radio, etc. Electrical load is simply any component of a circuit that consumes power or energy. These are some of the electrical loads that we have. So let's look at types of electrical load. Types of electrical load. I will try as much as possible to do justice to this discussion in this live webinar. So let's look at types of electrical loads that we have in the solar industry. So we have the resistive loads. We have the resistive loads. What do we mean by resistive loads? So resistive loads are loads consisting of heating elements. Resistive loads are loads consisting of resistive elements. So they include incandescent lights, toasters, ovens, space heaters, and coffee makers. They consist of heating elements. They consist of heating elements. So those electrical loads that consist of resistive elements are called what? Resistive loads. They consume lots of power. If you run resistive loads with your system, that means you want to destroy your battery as fast as possible. Except you run it during peak sun hours and during daytime. That is the best time to run this resistive load. Don't use your battery and run resistive loads at night. Don't use your battery and run resistive loads at night. Sometimes the client faults. They don't know the type of load they should be running during the daytime and the type of load they should be running at night. So if the client say, I want to be running AC, collect better money, construct a better battery bank for the client, and the system will still stand the test of time. So resistive loads are those loads that consist of heating elements. They include your incandescent bulb, toaster, oven, space heaters, and coffee makers, etc. So these are example of resistive loads. This is your hot plate. These are those old-time light bulb. One would be 200 watts. Please don't carry such light bulb and go where you install solar. You want to destroy that solar. So these are resistive loads. So inductive loads, I've already said that resistive load, they contain heating elements and they destroy your system easily. Because immediately your battery fails, your system don't go. It's no more solar. It's plug and play. So inductive loads, in the course of talking about the resistive loads, I have hints you on the implication, the disadvantage of running resistive. Because of heating element, they consume lots of power. They consume, example, if you use your iron to iron cloth, you see your light bulb will be blinking when the iron on because of the heating element. So inductive loads. So what are inductive loads? There are those loads that consist of motors. They consume lots of power during the startup process. So let's take a closer look at inductive loads. So inductive loads are loads that make use of motors in their operation. They make use of motors in their operation, like your fridge, like your photocopying machine. They make use of motors. When they start up, they consume lots of power, and it is advisable that you design this the inverter size times 3 of the power rating of the inductive load. But that is in theory. In real life, if you try that, your clients will laugh at you. Say, just this maybe 200 watt or 500 watt system that or load that I'm using, you want to give me 3 kVA, okay? I don't get that money. So there is a way you design them, and you will not have any problem. I'm talking out of experience. Sometimes what is written in the book, if you want to apply it in real life, you will run. So like somebody say, I want to I want to design a system for backup the days of autonomy. Oh, you will decline be able to pay. Not that you cannot design, but how many days do we normally have days of autonomy? Those days that we have days of autonomy, let the client know how to manage power. Case closed. Else you will not be able to do work for people. So you need to use your what? Common sense. I don't talk and use common sense. So inductive loads are loads that make use of motors in the operation. Using this type of load will require your system to be properly sized to take care of the starting process of these types of electronic loads. They are referred to as such loads, and when designing solar systems that will power inductive load, the inverter size should be 3 times bigger than the rating of the inductive load, so that it can handle the such effect during the starting process of those loads. Example: fan, vacuum cleaners, dishwashers, washing machines, and the compressors in refrigerators and air conditioners. So those are some of the inductive loads. You can see these are some of the inductive loads that we can show. So capacitive loads. So capacitive loads do not exist in a standalone format. No device are classified as capacitive in the way light bulbs are categorized as resistive and air conditioners as inductive. Capacitive loads in large circuit are useful in controlling power use. They are often included at electrical substations to improve the overall power factor of the system. Most loads we have, there is no load that is totally capacitive. Make use of only capacitors. So let's move on. Critical loads. This is very important. When we say critical loads, there are those loads that you run it 24 hours all year round, Monday, Tuesday to Friday, 1 week, 2 weeks, 3 weeks, 1 month, 2 months, throughout the year. You cannot shut them down. Those loads are called what? Critical loads. Critical load. Your CCTV camera is an example of critical load, as we will be seeing as we are going to see immediately. So note, critical loads are loads that can run for 24 hours every day, all year round, and you already know what the duration of usage is. One of the determining factor which sizing of solar system. When sizing of solar system. So that means these loads are run for 24 hours, and you know the effect of the duration of usage, how the effect that it plays when you are sizing your solar system. There are electrically driven loads backed up by a source that is independent of the normal grid power supply, in which such source of power is not allowed to shut down. So when you are talking about critical load, there are those loads that you are not supposed to shut it down. Somebody is in a life support, you need critical, is a critical load at that point. So you are not supposed to shut it down, else the person will go. So your CCTV is not supposed to shut down, and other critical loads that we have as we are going to see. So data centers servers, your servers in companies, maybe if you are you are having a server in your company, so those equipments are not supposed to shut down. So example of loads that are classified as critical in nature include data centers, servers, life support equipment in hospitals, life support equipment. Somebody is in life support and you want to shut down power. Oga, you know, Pudo, you have to be very smart too. So ATM in banks, all of them are critical load. CCTV camera, and let's take a closer look at phantom loads. Some people call it ghost loads. Some people call it vampire loads. We call it phantom loads, ghost load, or vampire loads. The day I hear of vampire loads, I was laughing. What this thing we see here? So, okay, let's say phantom loads are those electrical load that still uses electricity or standby power when turned off. So even when you shut them down, they still consume power. Were you aware of this? They are called phantom loads. Even when you shut them down, they are still drawing power from your source. So those type of loads, they are called phantom loads. So the above devices consume energy even while they are in off mode. These loads uses standby power to keep the clocks, timers, remote controls, and other features on home electronics working and ready to start the instant we press the button. Immediately you press the button, you see it pops up because it was not totally switched off. That means there are constantly drawing electricity. With most of these appliances, off does not really mean off. So we call them phantom load. Example, that's your television. That's your television. When you say you are short, please don't bring this kind of television close to the solar system. I beg, don't bring it. Never you try this. This is an outdated, throw it away. This is the smart ones we are using now. So this is a vampire load. So DV players, cable boxes, stereos, coffee makers, microwave, toaster, laptop chargers. Were you aware that all these things consume power even when you shut them down? They are called phantom loads. So how electrical loads affect the size of your solar system? How briefly, when we will expand this when we want to talk about system sizing. We will expand this when we want to talk about system size. There is more to sizing of solar system to what you know using those formula. Forget about those formula. I will tell you, forget about them. Let's show you how to design system that will stand the test of time. So how electrical load affect the sizing of solar system? I will just read it, and we have already explained it, and we still have more explanation in front of us. So the type of electrical load is one of the factors that determine the size of a solar system. That is the type. The type of electrical load is one of the factors that determine the size of a solar system. Powering critical loads will require the solar system to run for 24 hours all year, all day throughout the year, and this will definitely determine the design process. This system will be running 24 hours. Do you know what that means? Let it be CCTV camera, else you put in good number of backup. So powering inductive and resistive load require that the solar system should be appropriately sized to take care of this type of load. Inductive loads require your solar system to be sized times 3 of the inductive load to take care of the source effect of the inductive load. But I told you that most times you don't take all these things into consideration, because imagine somebody is using 1 point. Let's leave that. When we get to system design, we expatiate so that you understand it. So this brings us again to the assignment part of this module. The assignment part of this module. Let's look at the assignment. The very first assignment we have is, what is electrical load? The second here is, mention 6 types of electrical load you have learned. mention 6 types of electrical load you have learned and classify all the electrical load in your facility into the 6 types of electrical load. We tell you classify them. Now that we have mentioned them, use your own knowledge that you have gathered here to classify them. Because when you go for power audit, you have to classify these loads so that you will be able to interpret the data, and from there you will be able to understand the materials. This will really affect the materials you use during the solar system installation. So how does the type of electrical loads in your facility affect the size, the cost, design, and the solar system installation process? I've already said that the type of electrical load affects how you size, the cost, and the materials, including how you install. So all these things play a critical role when you are talking about going solar. You need to learn them. You need to be educated. You need to be groomed. So that is the reason we are holding this seminar, this live presentation, so that you can learn from the source. From the source, we are telling you raw truths in the solar industry, what those things that are making your solar system installation fail. And we are here to expose them. We are exposing those secrets. So all assignments are to be sent to Subway School at Gmail. Subway Schools 01. Please don't forget to put 01 at gmail.com. We will be back in a moment. Stay tuned.